Hey guys, welcome back to another video. Today we're doing another UKMT question. So the question is, a garden has a shape of a right angle triangle with side lengths of 30, 40 and 50. A straight fence goes from the corner with the right angle to a point on the opposite side, dividing the garden into two sections which have the same perimeter. How long is the fence? So to make it easier for ourselves, we can draw our diagram since they haven't drawn it for us. So we have our height here, our hypotenuse here, and our base here. So we can say that our longest side would be our hypotenuse, so 50. And then wherever 30 and 40 are placed, it really doesn't matter. But we'll keep 30 as our height and then 40 as our base. And then our fence length that we have to find out goes from the corner, where the right angle is, to the opposite side. So we can call this green line x. So we're basically solving for x. And to find this x, we can create a right angle triangle. So we're going to take that as a dashed line. And then with that, you would do Pythagoras theorem to find out x. So we have this dotted line. So we basically want to find out the length of this from that yellow line and the length from here to here. So we can label each corner. So we can go A, B, C is the corners of our larger right angle triangle, and then where we've made our blue dashed line, we could put D and E. Okay. So to find our AE and AD, we can find AD quite simply, because if we look at the two sections that the green line has cut for us, it says that the two sections have the same perimeter. So if we looked at the first section, which in this case is from ACD, so ACD, we actually have our lengths 30 plus x plus, in this case we can say y, equal our second section, which is CDB, so from here to here, like that. So that's basically 40 plus x plus, so now our DB becomes the whole length 50 minus our AD, which is y. So brackets 50 minus y. You can solve this equation. So we can put all our like terms together. So for example, we can put 30 onto the other side. So you're just left with x plus y equals 10 plus x plus 50 minus y. And then we can, when our x is minused, the x goes to the other side, the x's just cancel out. So then you just have y equals 10 plus bracket 50 minus y. And essentially our brackets can be taken out now. So it is just 10 plus 50 minus y. So 10 plus 50 is 60. So 60 minus y equals y. And then you put y onto the other side. So you basically get 2y equals 60. And therefore y equals 30. So now we know that our AD is 30. So we can rub that out. So now we know that from AD it is 30. So if we know AD is 30, then DB must be 20. And we can now find out the length of AE. So we can find the length of AE by using congruency. So we can, or similarity, so we can prove that the triangle AED is similar to the triangle ABC. So these are similar because they both have right angles over here and over here. They both have similar angles, these yellow angles that I'm making here, because these are adjacent angles, so they're the same. And they both share the same angle CAB over here. So if all three angles are the same, then they're both similar triangles. So if we know that, then we can do some fractions and some ratios to find out AE. So really, the ratio of AD the ratio of AD over AB would be the same as the ratio of AE over AC. So if we substitute our values into that, so AD over, so AD we know is 30 as we just figured out, and we know that AB is 50, which is already given, and then AE, which we don't know yet, over AC, which we know is 30. So then we can cross multiply and do 30 by 30, which is 900, which 900 equals 50 times AE, or 50 AE. And then we can do 900 over 50, which equals AE. And 900 over 50 is 18, so AE equals 18. So now we've found our yellow part here. So this part, so from A to E, it is 18. So then from E to C, it has to be 12, because 30 minus 18 is 12. So now we have these lengths. We can use Pythagoras' theorem to find out the length of ED, so by doing 30 squared minus 18 squared. So 30 squared minus 18 squared. So 30 squared is 900, and 18 squared we can do 18 times 20, which is 360, minus 18 times 2, which is 36. So 360 minus 36 becomes 360 minus 36 becomes 324. And then 900 minus 324 becomes 576. And then our x, or our ED, would be the root of that. So 5. So the root of 576. The root of 576, we can use known squares to build up to it. So we know that that 20 squared is 400. So on top of that, if we go up, then we find out that 24 is the square root of 576. So that means that ED is 24. So now we have our length of ED and we have our length of EC. We can use Pythagoras' theorem again to find out the length of x by doing Pythagoras' theorem on the triangle EDC. So now we just have, so x squared equals 12 squared plus 24 squared. So 12 squared is 144, and 24 squared, as we've just figured out before, was 576. So x squared equals that, and then we can add those together, which give you 720, which is x squared. So x is the root of 720. So 720 isn't a perfect square number, so we have to do some factorization to find what the root of 720 is. But then once you do all your factors and take them out and apply them, you get 12 root 5. So that is the answer of x. Thank you guys for watching our video. Please make sure to like, comment and subscribe, and we'll see you in next time's video. Bye.